I want to talk about that number e. Let's use a calculator to create a table of values to estimate this limit. If I start doing that and I let n be 5 or 10, I'll get the numbers on the right side, but I want n to go to infinity, so I want to stick in larger and larger numbers, like 100,000 or a million and so on. And as I do that, the right-hand side, 1 plus 1 over n to the n, as n gets large, begins to settle down to 2.718, 2818, 45, and so on. Notice that we're beginning to settle down to at least 7 or 8 significant digits. The limit appears to be this number, at least this number to 12 decimal places. This function, f of x, equals 1 plus 1 over x to the x power, as x is positive, does not converge to 1 as x goes to infinity, but instead converges to something near this number, and Leonhard Euler defined this number to be the limit of this expression, and this number is now called e. E, 2.71828184590452635 something, is one of the most significant and important numbers in mathematics. In fact, it is more important than the number pi. Here is how we define e as a limit, and it's a fundamental constant in mathematics. Now, if e is 1 plus 1 over n to the nth power, as n gets large, then it's worthwhile to change the expression to this. I'm going to replace n by 1 over h. Now, as n gets large, 1 over h is large, so h is small. So I'm going to think of n as being very large, so h is very close to 0. If h is close to 0, then, as we said a moment ago, n, or 1 over h, is very large, and so e looks like this. I've rewritten the expression at the very top of the page involving n to an expression at the bottom of the page involving 1 over h, or h. So here's how I think of e. Let's take this approximation and raise both sides to the h power. So I'm taking this approximation, raising things to the h power. On the right side, the exponent 1 over h times h simplifies, and we have an exponent of 1 that disappears. So e to the h is approximately 1 plus 1 over h, as long as h is small. Now, if e to the h is this thing, then subtracting 1 from both sides, we can have e to the h minus 1 is 1 over h, but I should have said this earlier, 1 over h is h. So e to the h minus 1 is h, as long as h is pretty small. So e to the h minus 1 divided by h should be close to 1. We've taken the definition of e using n going to infinity to rewrite it and say that whatever e is, e to the h minus 1 over h, as long as h is small, should be close to 1. So we started with this original definition of e given to us by Euler, and we've turned it around and created this limit. As h gets small, e to the h minus 1 over h goes to 1. We now have two equivalent definitions of e. You can define e as this limit as n goes to infinity, or you can define e as this base of an exponent inside this expression so that we get 1 as an answer. We'll return to these results later. We will certainly need them.